Let's apply some of these formulas that we just saw in a previous video. Find the equation of the tangent line to x equals e to the t times the sine of pi t, y equals e to the 2t, at the point where t is equal to 0. Remember that the slope of the tangent line is given by dy dx. In this case, it's dy dx evaluated at t equals 0. But dy dx is dy dt divided by dx dt. Therefore, we need dy dt and we need dx dt. Since y is equal to e to the 2t, dy dt is 2e to the 2t. Dx dt is e to the t times the sine of pi t, and so we're going to use the product rule. And you'll find that the answer can be given by e to the t sine of pi t plus pi times the cosine of pi t. dy dx then, as we just said, is dy dt divided by dx dt. I do recommend that you write it out a lot so that you know it when you need it. Is equal to 2e to the 2t in the numerator divided by e to the t times the sine of pi t plus pi times the cosine of pi t. We can see here that one factor of e to the t will divide out. You may be thinking, wait, we want this derivative at t equals 0. Couldn't I have just put t equals 0 in place of dy dt and then also computed that for dx dt? The answer is yes. I just didn't feel like it right now. So now we can say dy dx evaluated when t equals 0 is going to give us, in the numerator, 2e to the t when t is 0 is simply 2. In the denominator, if t is 0, then the sine of pi t is 0, and we end up with pi times the cosine of 0, which is simply pi. That gives us our slope. Now we need a point. For our point here, we are told it's at the point where t is equal to 0. Well, x of 0, since x is equal to e to this t sine of pi t, x of 0 is 0. Y of 0 is equal to, since y is e to the 2t, 1. So we have a slope of 2 over pi. We have a point that's 0, 1. That's a y-intercept. Our equation is y equals 2 over pi x plus 1. To help visualize what we've just done, we can use GeoGebra's 2D graphing tool. You can find it by Googling GeoGebra 2D graphing tool or by looking at my website. The way we enter a parameterized equations into GeoGebra is as though it's an ordered pair. So I start with parentheses, and the first coordinate is e to the t times the sine of pi t, and for pi I just type pi, it knows what I mean, comma, then for the second coordinate, e to the 2t. And I see that it's giving me part of the curve. It actually doesn't go to the left and to the right of 0, 1. And when we hit enter, we see that it's actually defining the parameter to go from 0 to 2 pi. I don't want that to happen. I want it to go from negative 2 pi to 2 pi, just so I can see more of the curve there. And so now we have this curve. And I've gone ahead and plotted the point 0, 1. That was the point of tangency that we were given. And the equation that we came up with, y equals 2 over pi x plus 1. And we can see that what we have just come up with is the tangent line to the curve. Notice I didn't have to type in the word curve or anything like that. I just typed in starting with the parentheses.